good afternoon. My name is James Veselka, and I would like you to take CARE on Mars. And so CARE, of course, is an acronym for Communication Audio Range Ergonomics, which I will get into shortly. But first off, my research project deals with the communication system out at the Mars Research Station. So they have Motorola two-way radios, which work relatively well in ideal conditions. Here's what they look like. They have a 27-mile range, as I said, in ideal conditions because, as we all know, the sun and weather, everything affects radio waves. And then the max output power is 1 watt, which is decent, again, for this type of radio, but it's not necessarily the greatest. It has a one-ear headset, which while I was out there on crew 128B, we could not get the headsets to work at all. So it was rather interesting using the radio while on EPAs. And another feature of this radio, they have Vox, which is voice operated activation transmission system. And what that means is all you have to do is talk into the mic and it picks your voice up and you can do hands-free operation. It's kind of like Bluetooth, but it cuts off after you stop speaking. So then the other person using the radio can speak back, since radio communication is one way. And this one had 3 levels, 3 being the most sensitive and 1, of course, being the least. And this radio used ultra-high frequency, which is a frequency range of 300 to 3,000 megahertz. This radio used the 462 megahertz. And with the UHF, it's short wavelengths, as you see here, and it's more suited for indoors because of the short wavelengths. You can travel through materials rather well, except for when you apply it over long distances, especially with hills and valleys and change in elevation. They tend to cut out because of the length of the wave. And then here is a picture of the placement of the radio. And if you see on the picture here on the bottom, the duct tape, that's the radio. Because since we didn't have the headset, we had to find a way to put the radio underneath the helmet while staying in simulation. So it was interesting using, and you couldn't use it while you're driving your ATV. And so again, here is CARE, my project, the Communication Audio Range Ergonomics. Basically what I wanted to do is to simplify and improve the communication system out at MDRS to make it easier to use, so that's the ergonomic issues, as range of motion, and to increase the distance, so to improve the distance, because when you go out on the EPA out at MDRS, you can go up to, I think we went like 1.5 miles. But within that 1.5 miles, there's, I don't know, maybe 2,000 feet. Some places change in elevation due to all the hills, and depending on your definition of a mountain, many mountains. And also, by improving this communication, you actually improve the simulation, because when you go to Mars, you're not going to have a system that will only go 1 mile, because you're going to want to explore, say 5 miles in a day, or maybe 10, depending upon your oxygen supply. And so my system used the Baofeng UV5R ham radio. If you're not familiar with ham, it's just a slang term for amateur radio. And here's a picture of it. And these are really nifty little radios. They have great range, up to 30 miles in ideal conditions. They have the max power output of 4 watts, which is considerably greater than 1. And it also has the possibility for stereo sound and a 1 microphone headset, which is what I created. So this picture, as you see here on your right, is the interior system of my headset, the wiring and the microphone and the plug that went into it. And as you'll see in 2 slides, the finished product. And the Baofeng radio also had Vox, but it was a lot could say was better in some aspects, mainly because you could adjust it within 10 levels. Now, the scale for this box was backwards, so 1 was the most sensitive and 10 being the least sensitive. And a great feature is that this radio uses both the UHF and also another frequency range called VHF, or very high frequency. It has the range of 30 to 300 megahertz on the VHF, and the frequency that I used was 146.58 megahertz. And with the VHF, they have longer wavelengths, so they tend to bend around objects better. So hills and valleys, things of that such aren't quite as the obstruction as with the UHF. And is also more suited for outdoors. Because if you think about, I'll use the television for example, before they switched analog to digital, you could have a clear signal on any day. With the free digital TV that they have now, the wavelength is shorter, and it's not the standard VHF wavelength, so it cuts out depending upon weather. And so with this project, I had a few requirements. I had to become a licensed ham operator, which I did, and that's because with ham radio, you actually register with the FCC to be able to use it. My call sign is KF5TZO, for any fellow hams out there. And I also had to learn how to operate and program the radios to the frequency that I was using, and to have a working knowledge of circuits, since I did build the headsets and the coaxial cables from scratch, mostly. I mean, I bought components, but you still need to know, because if you put positive to negative, sometimes bad things will happen. But thankfully I didn't run into that. And then also I had to build and test the headset, because once I got out to MDRS, I wasn't, you can't really take a full toolbox on an airplane. So I had to make sure and double check that everything worked before I left, because of the limited tools available at MDRS, and it would be the same as if you went to Mars, because you can't take everything because of weight requirements and fuel requirements and food is everything else, and that such. And I also created comparison contrast charts to compare C.A.R.E with the current system that they have out there, and to learn how to solder. The soldering was involved in building and assembling the components. And then to know the difference between the UHF and the VHF, because of course both radios use different frequencies. And then so here are some of the materials that I used. I used 6 1-watt, 1-inch speakers. Here's a picture of them. And they're very small, and the reason I used 6 of them is because I built 3 headsets. But they have a great sound, especially when they're right on your ear, like a set of headphones, which is what I was going for in the headset. And then I used the actual headsets that came with the radios. They were just a 1-ear headset, but to salvage the plug, it's kind of hard to build a 2-prong audio plug with different sizes. So I was able to salvage and reuse the plug and as well the microphone due to time restrictions, because I was going to wire in a different microphone. And then I also used 3 baseball hats, because that helped with the stability of the headset. The cap, it fits to your skull, much like, well, skull cap. But it's a lot better than the standard ear thing, because when there was a previous crew from NCC that went out to MDRS, when they used the headsets that came with the other radios, they had to actually use medical tape around their head to keep the headset on, because it only clips over your ear, and as you know, when you move around, things don't tend to stay where they're supposed to. And then the coaxial cable and connectors that I put together, and also the radios. And then the Velcro and cotton fabric, because I made, here's a picture of it, it's later on. But the cotton was what housed the interior wiring, and the Velcro actually went underneath your chin to secure it, much like a bicycle wheel. So, and then here's how I built it. I wired all the speakers together. I used series wiring, so I used the same wire. I didn't have to do separate wiring for that and the stereo sound. And then, as I said, I reused the pre-made Valfang headset by reusing the cord and the plug and the microphone. Yeah. And here is a picture of some of the soldering work that I did. It's not the greatest, but it's a heck of a lot better than when I started. Because I actually learned some techniques such as tinning for all your soldering buffs. It's when you add some solder to the soldering iron so it flows better than when you solder the components together. And all right, here's a picture of the internal wiring as you saw in the first slide. And then I also used jewelry wire for the microphone because I needed something stiff to resemble, a real headset. So with that jewelry wire, you were able to adjust it and to keep it on your mouth, and it wouldn't go away. And then with the baseball hat, since you have limited space in the helmet, I had to cut the bill off. And the reason that I chose to cut the bill instead of rip it out seam-wise, one, that would have taken more time, but two, you would have lost the structure in your baseball hat. Because that's kind of what the bill does. And it ended up working great with the short bill because it kept the structure. And then I inserted the wiring into the flaps. So this is one big flap that goes over the top of the baseball hat, just a seam, and the Velcro that attaches to either side of the flap. So here is the final product. So as you can see, the headset is secure. I have the baseball hat on my head. I can move, 360. It's not going to fall off when I bend over. And I have the Velcro running underneath my chin. So the speakers are secure over my ears. And that also helps the microphone stay in place. And then one of the things that I found out while we were out there was the placement of the antenna. Because originally I was just going to have the antenna duct taped onto the helmet. But that doesn't really work because the coaxial cable over time and just normal movement loosens the duct tape. So I was fortunate enough to find some rubber tubing and run the antenna through that and then seal it up. And then as you see here, I was able to duct tape it to the pack. So it was a great stationary antenna, and you don't have to worry about it falling off. And there's better reception that way as well. And then so here is my analysis. I did comparison contrast, as I said earlier, from C.A.R.E and Motorola. And so in this process, I did the communication distances using GPS. I mapped where each one cut out and the furthest distance from the hat that they made. And then I also used clarity and ease of use, the ergonomics. So this is like the sound of the headset itself and the use on the ATVs while on EVA. So here is the distance. And the C.A.R.E with the Valfang radio, as you can see, it's some blue flags. And they did up to 1.3 miles, which is the furthest that we ended up going out. And along the way, it did cut out because of the hills, because again, line of sight is a big thing. And since it had more power, it was able to still connect at the furthest point in linearity with the hat. The red flag is the Motorola, which that's the last point that I actually got connection. Which really is just bad because when in simulation safety is the #1 thing, it would be on Mars. And if your radio doesn't work past that point and someone gets hurt later on, you have to wait for that other person to get back. So this C.A.R.E also eliminates most of the worry of the people staying at the hat while they are still on EVA. And then so for the clarity and the ergonomic comparison, I made up a scale. For clarity, I used person to person and between the hat and the person. So basically, communication with the hat while you're on EVA, and then also while you're out on EVA, you need a microphone communication system to communicate with your fellow mission operators because of the helmet of the spacesuit. You can't, it's like a barrier, you know, it's thick plastic. So you need something to speak through it. And then for the ergonomics, I also made a scale on activating. So as I said earlier, using the Vox activation and the headsets. So the current system, the two-way Motorola MJ series, they didn't work very well, mainly because I couldn't get the headset to work. So that's the only semi-flaw in the comparison. I couldn't really truly compare the headsets since they didn't work. But I was still able to compare the range, in which it earned a 3 out of 10, you know, because of the distance, and it was also hard to use without the headset. And it also earned a 3 in person-to-person because without the speaker over your ear and it duct taped underneath your helmet, the speaker was almost pointed out of your spacesuit, which was rather interesting to try and talk over. But it worked a little bit. Again, it wasn't really true to the reality of what simulation should be. And then the activation only earned a 2 on the ergonomics out of 10, just because of the fact that with the way that we had to clip them on, they didn't stay stationary while you were going around the curves and over the dips and bumps of, you know, the natural formation of the road. And C.A.R.E, of course, did wonderful. The headset worked. I had full range of mobility. I had great range within the hat. The stereo sound, at least in my opinion, is, even though I'm young, I still can be hard of hearing sometimes. And so having both speakers on both sides, you know, you can always understand what the other person is saying. And also earned a 10 in person-to-person as well as distance. As I said before, it's clear as daylight. It was great. And also earned a 10 in ease of use because it was easy to activate while riding on an ATV because of the box. So you could actually speak while you were driving. So if someone in the back wanted to pull over to check out a rock formation or something, they could just communicate without having to take a hand off of the steering of the ATV. And that's, you know, improved safety by almost 10%. So in my conclusions, the hand radios work a lot better than the Motorola over long distances. Now, short distance, they're probably pretty close because, again, the wavelengths don't really make that much of a difference over a short period. And the VHF is better for long distance, which is the main reason why the Baofeng radio is better. And also they have more power, which again makes a big difference. And so, as I said before, the safety increase is the communication with the hat. You know, the furthest location of your EVA, you can make contact without that much difficulty. And of course, since all of these wonderful things increase, the ergonomics also improved. And one Easter egg that I found by using the box on the ATV was that you have to turn it up to 8 because when I was building it, I didn't think about the engine noise. But since the box was adjustable within 10 levels, it was not an issue finding the right level to adjust to. So you could still speak and the radio would cut off. Because what the ATV noise does is if you have your Vox at a lower level, so like on the Baofeng radios, if you have it on 1, it's really easy to activate, and the noise of the motor, the ATV, turned it on instantly as soon as you started the ATV. So since radios can only work one way, that kind of killed communication. But with the Vox being adjustable, I was able to find it. And so again, stereo sound makes a big difference. And elevation also makes a difference, as I said before. That was one of the interesting things to find out while I was out there, how big a difference, you know, even 50 feet made in communication with the hat. And so then, as I said, the mobility of the headset increased have to worry about it falling down or falling somewhere inside your helmet. Because again, with the reality of a simulation, you can't take your helmet off. Because when you're in space or you're on Mars, there's no atmosphere, take your helmet off. It's not a good idea. And future opportunities for this project, there are many. It's such a great starter. I've just barely scratched the surface. The wiring in the headset, I would like to make it removable. That way you could wash the cloth parts. Because again, it does get kind of hot out in the desert. And just general heat within the spacesuit. And then I would also like to make it more durable by using better wiring. The wiring I used worked out fine, but they're not really, so the wiring that I used, it was the stiff wire, it was one strand, and that's great for soldering because it makes it really easy to solder a point to it. But what happens is over time, if you bend it a lot, it can break, and then you lose connection, and then there goes whatever you're wiring. So I would like to use this stranded wire because it has a better flexibility for connection. And also you could add an external antenna to the hat, and that would greatly increase communication range as well as clarity. And then also to make a hand mesh net or a repeater to put up every so often, that would eliminate dead spots overall. And all that really is, if you think of a cellular network, they have antennas in multiple places, say 100 to 200 miles apart, depending on how strong the antenna is. They overlap, and that's why you get great coverage in certain areas and not so great coverage when you're further out of range. So that's all that would do is you would make a great coverage area. And so that would be reasonable to 2 miles because without it, it did 1.3. So you could do 2 miles, you could maybe even do 10, depending upon how much power you gave to each component. And I would like to say thank you to a few people. For my advisors, Dr. Smith and Mr. Benton. I learned a great deal of electronics from both of them, and it wouldn't have been possible for me to learn that much information in such a short period of time without them. And then also to Dr. Andrews, our crew director and person responsible for Mars 101, and also the Science and Engineering departments at McLennan Community College for the program, which is where I'm from. And then also to everyone in my crew, crew 128, and this is our crew patch that we have on site. So thank you for your time, and if you have any questions, I'll be happy to do my best to answer them. Yes, sir. Well, the expansion with the ham or just my project in general? Okay, so to build 6 headsets, just doing the headsets and using ham radios was, it's only $333. So that's just the headsets themselves. Now I'm not quite sure on what a repeater and an external antenna would cost, but just using the ham radios would make a big difference in my opinion.
Well, we're putting up a review. Would you like to help us with this project?
It depends. I may be kind of pressed for time. I'm going to Texas A&M, so keep in contact because that would be very, very interesting.
Is the steering located outside?
The helmet helped eliminate most outside noise. Because it was solid. Were you referring to the microphone? Or the speakers?
Outside.
Well, okay. That's a very good question. So So the speakers, they work like a set of headphones, except for not the noise canceling type of headphones. Because if you have, if you're talking to someone on the headset and something bad happens, and most times if you don't see it and you're not on your ATV, you could most likely hear it, depending upon if you have your helmet on or not. But more than likely, yes, you would still be able to hear something exploding, for example, if that would happen. Hopefully that's